Well, hello there, math fans. Someone in my Calculus 3 course just answered a question that I asked a while back. This actually comes from our first homework set in Calculus 3, where we're giving you 2 points, and we say, try to translate what it would mean for a point to be twice as far from one point as the other, and think of the collection of all such points. So it's more of a translation question. I'm going to show you a couple things here. So here's an example of a point, that purple dot, that is twice as far from the green dot as it is from the orange dot. And this is not an essential question for our course, but it's a chance to use the distance formula, and it turns out that it's a sphere. So you can I'll move this around a little bit. Oh, I made those numbers so big. So here's a few examples. So there's more than one point that does this. There's quite a few. You can see them. In fact, if you keep moving around, you start to realize, oh, it's some sort of circle in 2D. And it's actually a sphere. So that's kind of surprising. So the challenge for students is they have to just write down the definition of distance, simplify it, and they end up getting a sphere. So it's a chance they have to complete the square. There's lots of fractions. It's painful. And that's what we get. And so if anyone else can solve the general, that's the question. So the general question, what if it's not twice, but what if it's 3 times as far? So here's 3 times as far. Here's 4 times as far. So that green line is 4 times the orange line. You can see it makes it quite a bit smaller. Now, an interesting question is, what about if you're 1 unit away from both of them? Ooh, not 1 unit, equal distance from both of them. It's this. And if you're like a half, it goes to the other side. So I thought that was kind of cool. I never really had asked that question until I made these visuals. Okay. So the fact that the student solved this, so anybody else who can find the general solution, meaning instead of multiplying by 2, multiplying by 1.1 or 1.3, and replace the 2 by alpha. Can you find the general pattern for the center? I will share this with you. But since someone solved it, I thought, hey, how about a follow-up question? So I thought a little bit about a few different things, and then I realized that this comes from a more general problem in 2D. So I'm going to say a few things about that. So ultimately, this comes from the Circles of Apollonius. It's an old Greek problem. So if you want to search that up, you could study a little more here. And it's an observation that, among other things, that this is another way you can describe a circle. So you can see this little picture of this, where we have these 2 points, we have these 2 distances, we have a certain, ratio we want. In this case, we're doing 1 is twice the other. So we're doing like 2 to 1. And that does give a circle. So that's kind of surprising. But there's a bunch of interesting other things to ask. And there's a whole bunch. There's art. There's things that go with this. So if you're interested, one interesting question. There's one which is if you draw a whole bunch of them, what happens? They intersect and they're perpendicular. Another question is, if I give you 3 circles in 2D, can you find a circle that touches all of them that's tangent? It turns out there's more than one answer, because you could go around all of them, or you could be tangent in other places. But an interesting question is, can you actually find the equation, given any 3 circles, that goes around them and just touches them and closes them? I don't think that's an easy question. I would be interested to see what happens in 3D. So send me your Desmos where you find, given 3 spheres, I would like the sphere that's tangent to all of them. I'd like to know what the center and radius is. It's going to be messy. It's going to depend on the other 2. If you want, you could fix kind of 2 of them to have nice values and just work with it. So there's a question for you. Another question is, what happens if you do that same problem? You take a circle and you put these 3 tangent circles in there, and then you put tangent circles that are tangent to all of them, and you keep going. what do you get? You get this what's called Apollonian gasket. I've seen, and there's many of these, not just one, but here's one with sort of equally spaced patterns. It'd be interesting to make a 3D version of that or print something. There is a lot of questions you can ask. In a previous video, I even talked about a different sort of tangent circles, which is this so-called fairy sequence. But that has more to do with fractions than it has to do with anything else. So, and there's plenty. Oops, I didn't mean to show just some of my graphs. So anyways, that's my question for you. I think the interesting starting place would be if I hand you 3 spheres that don't, let's say they don't overlap. So 3 non-overlapping spheres, maybe some basic ones to start with. Maybe all of them have radius 1 or something. Can you find a sphere that goes around them? Can you come up with one example as a start? And then could you come up with forms? I think that's a more challenging question. I think that if you read this Wikipedia a little further, there's some comments on that. Actually, I think if you go here, the problem of Apollonius. And I've never studied this. So this is what I like about students asking me questions. I thought I saw a theorem in here about the relationship. So if you search a little bit, if you don't want to find it, there is a relationship by the radius of the 3 starting circles and the resulting tangent circle. So you can actually prove something about the connection between the radii. It's not a nice relationship. So anyways, that's for that student. Is if this interested you, I think there's plenty more to be done. Since this student is in my class on calculus projects, this probably would make for an interesting, calculus project at the end of the term. Start with the question we have in the homework, ask a more general question, and then tie it in with Apollonian circles, but give the 3D version of that. So thank you so much for answering that question. Sorry to give you more.